So we have this reaction. Same explanation. We are on the second one, of course. Take note of that. So you have H2SO4 plus 2KOH going into K2SO4 plus 2H2O. So how did this equation come about? Now, first of all, let's break the ions, or let's break the reactants into their respective ions. And as we are doing that, do your best to ignore the numbers we have in front. For example, the number you have in front of the KOH, or potassium hydroxide. Ignore that number for now, and also ignore the number in front of the water, that is H2O. The reason I'm asking you to ignore them is that the equation you see at the top is actually a balanced chemical equation or reaction. So I'm going to teach you how to write it and then how to balance it to get the reaction or equation you have at the top. So let's get started. Breaking of the products into their respective ions. We have H2SO4. H2SO4. For the H2SO4, its ions are H plus and SO4 2 minus. The H plus is the cation ion, the SO4 2 minus is the anion. Don't be confused. You see, especially for the SO4 2 minus, you'll be asking yourself, why is 2 at the top? 2 minus, why is it 2? Take note. The 2 in front of the H, you see the H subscript 2 SO4, that 2 in front of the H actually came from the SO4. So that 2 is from that side. So the 2 is from the H subscript 2. And the H plus is just positive 1. You see, don't be too scared. The more you practice this kind of chemical equations, the better you become when it comes to writing them into their various cations and anions. And when you even become better at writing this kind of reaction, you don't even need to write the cation and anion form before writing chemical equations. What about the KOH? The KOH can also be broken down into K plus and OH minus. And like we did in the previous one, the cation from the acid, which is H2SO4, will bond with the anion from the base. And the anion from the base is OH minus. So H plus OH minus gives us water. Gives us water. Gives us water, H2O. Then the K plus, that is the cation, will react with the SO4 2 minus from the H2SO4 to form K2SO4, and that is the salt. But here's how interesting it gets. The 2 subscripts, the K2, that subscript 2 is actually coming from the negative 2 on top of the SO4 2 minus. So that's how interesting chemistry can be sometimes. The H2O, that is the water and the salts, are collectively known as the products. So let's keep that in mind. So now let's combine the products and the reactants. The reactants are H2SO4, that is the acid, and then the base KOH, potassium hydroxide. These two, H2SO4 plus KOH, react to give us the product K2SO4 or potassium sulfate plus water. Now this is our reaction between an acid and a base to form salts and water. And remember, a reaction between an acid and a base to form salt and water is known as a neutralization reaction. But as usual, we have to check if this reaction is balanced or not. So next step, checking and balancing of reaction Are you ready? Remember, spoiler alert, this reaction is not balanced. So let's try to balance it. First step, what do? Well, before we go ahead to go through the steps, let me just rewrite this reaction, the unbalanced one, the one you see at the top. Let me just repeat it at the down, because we'll be doing some kind of operation on it. So pay close attention. Things are going to get quite tricky and interesting. But don't be discouraged. I believe you will be able to do it. Are you ready? Okay, if you are ready, then subscribe to the channel if you haven't. Subscribe to the channel fast before we proceed. Okay, so let's go. Now, first things first, we have to identify the reactants and the products in this reaction. So, what are actually the reactants? Have you found them? Yes, I know you have. That is the acid and the base, H2SO4 and KOH. So if you identify the reactants, what we have to do is to write out the elements we have at the reactant side. So what are the elements? For H2SO4, we have hydrogen, we have sulfur, we have oxygen, they have potassium. Then you see that oxygen appears in the potassium again, the hydrogen appears. So here are the elements in the reactant: hydrogen, sulfur, oxygen, potassium. Remember, we've not repeated the hydrogen twice. Yes. And we've also not repeated the oxygen. We only need to write one of them. What about the product side? Remember, the elements found at the reactants repeats at the product side. So for the product, we have hydrogen, sulfur, oxygen, potassium. After writing out the individual elements, what do we have to do? We have to write the number of them we have in the reactants and the products. So for hydrogen, what do we have? We have, for the sulfuric acid, H2SO4, you write that the hydrogen has a subscript of 2. So H2SO4. So the subscript of hydrogen is 2. So you have 2 hydrogen over there. Then we have another 1 hydrogen at the KOH. Do you see that? KOH. So that's another hydrogen. So 2 plus 1, that gives us 3. But here's the point. We do not write 3 just as 3 that way. Write them as separate. So you write hydrogen, you have 2 plus 3. Then check for the sulfur, oxygen, and potassium. For the sulfur, we have 1. For the oxygen, we have 4 in the sulfuric acid and 1 in the potassium hydroxide. And for the potassium, you have only 1. So this is how to write out the various elements and the numbers you have in each of the compounds. So hydrogen 2 plus 1, sulfur 1, oxygen 4 plus 1, and potassium have 1. If at this point something is quite not clear, then quickly run to the comment section. Really run, like literally run to the comment section and write your confusion or explain yourself what you need help in your comment section. Now let's move on to the product side. For the product side, hydrogen, sulfur, oxygen, potassium, we have, these are the quantities we have: hydrogen 2, sulfur 1, oxygen 4 plus 1, potassium 2. I think you should know why we wrote the numbers that way. Now let's cross-check and see if this chemical reaction is balanced or not. For hydrogen, we have 2 plus 1, that gives us a total of 3. 3 of the hydrogens at the reactant side. What about the products? We have only 2. So the 3 at the reactant is not the same as the 2 at the product. So that means the reaction is automatically not balanced. But we can check the rest. Sulfur is 1 at the reactant and 1 at the product. Good. Oxygen, 4 plus 1 is 5. And for the product side as well, it is 4 plus 1, 5. So it's also the same. For potassium, it is 1 for reactants, 2 for products. So that means the entire chemical reaction, that is sulfuric acid, the acid, plus potassium hydroxide to give us Potassium sulfate and water is not balanced. So how do we balance? How do we balance the chemical reaction? The one we have on the screen, how do we balance it? Easy peasy. Yes, it's really easy, like literally easy. Sometimes as students, our problem is we get so scared. We fear problems that actually do not exist. So believe when I say it is easy, just pay attention. If so far there's something quite confusing, don't worry, maybe this is the first time. Take your time, watch the video over and over again. So you see how much I've taken my time to explain? That means I know you'll be able to get it. So let's see how to balance this chemical reaction. How do we do it? Here are the rules. When it comes to balancing chemical reactions, you will just look at the side, either reactant or product, the one that is lacking, and then look for a factor or look for a number you can use to multiply, not add. You can use to multiply the lacking side to make it equal to the one that is more. What does that mean? For example, I'll start from the one at the down, the potassium, the K. You realize that the potassium is 1 for the reactants. But when it comes to the product, we have 2 of them. What can you do to 1 to make it 2? Remember, you multiply, we do not add. So what can we do to 1 to get 2? I think you guessed it. 1 times 2 will give us 2. So what does that mean? So we just pick the 1 for the potassium and multiply it by 2. So 1 times 2 will give us 2. So now you see that the potassium at the reactant side is now equal to the potassium at the product side. You see, I told you it will be very easy. Yes, so first obstacle out of the way. So now what do we do with the 2? This 2, you will write it in front of the potassium compound, the one KOH. Write the 2 in front of it. Remember, the values you use to multiply, you write them in front. You don't write them as subscripts, so you write them in front. And after writing them in front, that means it's going to affect what you are doing. So now look at, so the potassium is now 2 and the potassium for the product side is also 2. But here is one interesting thing. Take note of this. Remember, or you've seen that we've written 2 in front of KOH, but we've done something interesting. The 2 affects not only the K or not only the potassium, it affects the oxygen and then the hydrogen. That is what is happening. So the 2 if placed there is affecting the oxygen in the KOH and then the hydrogen in the KOH as well. So that means the 2 is going to multiply the oxygen and then the hydrogen. Are you confused? Sorry, don't be confused. Take your time. Rewind, play, take your time, understand, proceed. What did we say? You see, we're trying to actually balance the potassium. But when we did and placed the 2 in front of the potassium hydroxide, it affected the oxygen and the hydrogen. So we have to indicate that as well. And take note, the times 2 for the oxygen, you realize that we didn't put the times 2 in front of the 4. But I placed it, we multiplied the 2 with the 1 rather. Why is that the case? Because that 1 is from potassium hydroxide. The 4 of the oxygen is from H2SO4 or sulfuric acid. Meanwhile, the 2 is multiplying the oxygen from the potassium hydroxide. And the same principle applies for the hydrogen. So I think that makes sense. Good. So we've solved the problem, but I think we've created another problem. So let's check our elements and see if they are balanced. For the potassium, we have 2 for reactants and 2 for products. Good. For the oxygen, we have, remember, initially we have 4 plus 1, that gave us 5, and it was balanced, but now we've changed it. Now we have the 1 times 2 is 2, plus the 4 is 6. So now the reactant has 6 of the oxygens, while the product has only 5. Our reaction is not balanced. And then the sulfur is still 1, intact, and the hydrogen is now 2 plus 2. That gives us 4. How did we get the 4? Remember, 1 times the 2 in yellow, that gives us 2, plus the already existing 2, that gives us 4. So now we have 4 hydrogens in the reactants and only 2 in the product. So that means our balancing is not even complete. What do we do next? We balance. You can start from anywhere, but for this particular question, I feel it's quite easy if I try to balance the hydrogen before proceeding. How do I do it? Remember, we have 4 hydrogens at the reactant site, but 2 at the product side. So what can we do to the 2 hydrogens at the product side to also get 4? You guessed it right. You multiply 2 by 2. So 2 times 2 is 4. So now let's check again. We have 4 hydrogens at the reactant and 4 at the product. So the hydrogen 2 is balanced. But after multiplying by 2, what do? Do we just stop over there? This 2 is multiplying the hydrogen, right? It's multiplying the hydrogen in the water. So you have to use this 2 and write it in front of the H2O, the water molecule. So write the 2 in front of it. I know you are thinking, did you not say this is easy? Yes, it is easy. It is easy, but it might look difficult for you. Maybe this is your first time and you know how the brain works, right? The brain likes easy things, repetition. So the more you repeat this, the easier it becomes for the brain to actually understand it. So don't feel your first resistance from the brain means it's too difficult for you to understand. Well, let's continue. So take note. We place the 2 in front of the water molecule. We are trying to adjust the hydrogen in the product side to make it 4. But remember, as we place the 2 in front of the water molecule, it affects not only the hydrogen, it also affects the oxygen. So the hydrogen has become 4, but the oxygen that is attached to the water molecule or attached to the hydrogen also becomes times 2. So at the product side, the 1 over there also becomes 1 times 2. That one is for that 1 hydrogen, or that 1 oxygen is actually from water. So as we are trying to adjust the hydrogen, we have also changed something about the oxygen. So now let's cross check again. Hydrogen for the reactants. 2 plus 1 times 2, that gives us 4 for the reactants, and 2 times 2 for the product gives us 4. So the hydrogen is balanced now. Sulfur is 1 for reactants and 1 for products. Balanced. What about oxygen? For the reactant side, we have 1 times 2 is 2, plus the 4, that gives us 6. So 6 for reactants. What about products? 4 plus 1 times 2, that gives us 6. So oxygen is also balanced. And potassium is also balanced. 1 times 2 is 2 for the reactants, and for the product we have 2 potassiums at the product side. So our final equation or reaction is now balanced. Is it easy? Yes, it is. Go back, replay, take your time, understand. Because the same step can be used for any kind of reaction.